walking up, the student had her shoe untied. I said, hey, your shoe's untied. Can you do that for me? No, I can't. My hands are full. Can you tie it? I looked at Dr. Raymond. I wouldn't care if she was 6. I'm gonna go tie her shoe. Yeah, no, this is our problem. I've actually used that example. No, she ties on my hands, well, she's on mine too. Well, walk on up there and then put your stuff down and tie your shoe. Can't even tie my shoe. That's our problem. I think they're so needy for attention. Any kind of attention. Oh, it's unreal. I've got a kid. He came from Farmington. He really likes me, and so I had a day that had cups for water and stuff like that. And I had my fountain, and I'm just kind of running over like the amount of people and kids and stuff. And Marcus is right, it's like 50 cows. And they just he'd come by like on a random time, and I had a cup and you know, like I shouldn't see you this much. Like we should.
I heard some of my 5-year kids talk about one of the SROs has they did that.
We have a lot of students. Yeah.
I know, but
I agree with that too. And so I suggested it to Reeve and I were talking on the water deal about giving everybody a water bottle. Like, you know, like, here's your yonder pouch, here's your Chromebook, here's your water bottle, so at least they have a water bottle to stay hydrated. Because I don't want to just give them out the other one.
Look at us.
They get free breakfast.
Oh, it's on here.
So they get free breakfast.
Got the heat turned on.
But they use scrap us. Typically.
Sure,
So if
nice.
you're right, if you're right,
Oh, no.
you should be able to do that.
I'm seeing,
Like bottled water, like that.
Oh, I genuinely forgot about it. He's handed out the week before class.
Well, that's what I thought that too. Yeah. That would be a two, that's.
It's a little hot in here.
it is high.
That heat is on.
It's a little toasty. Where do you see the numbers? Dig, you're like right over there. You're like number 6. Yeah. Oh, I moved one desk over. Fantastic.
I just need to
Hey, I got the best desk in the house.
I'm not sure what the system was. So
Ellie
many birthday
Henderson.
parties for me, they
What's that talk about? Oh, okay.
I had
You don't find that
House's
time?
head edited on.
Thank you for just stacking hundreds of papers on my desk. That ain't even mine.
They had a picture of me and the bishop. Because one of the brothers on the post. For some reason. Mitch just sent me a video of her dancing.
Hey, I'm Simeon Brill.
That's so sweet.
Do I look
Oh
like
my gosh,
Simeon
Mom,
here?
we're twinning shoes.
Pretty close to them.
Okay.
Yeah, I would agree.
You guys have different eyes, but
Our hair's the same.
I
You did it?
got 50, bro. Send you backwards.
Hold on. Let me set my stuff
I
there.
just got number 14 back.
Wait,
Oh, I got one. I think it's
here? No.
190.
today.
Yeah. We lost on the block.
I love the outfit. Really?
So sorry.
No, it's okay. I don't even mean to.
One year.
I need someone to walk out.
It's 29 over here, right? Let you
I just got paid. Oh, look,
It's the implicit differentiation. Or you got
I got number 6 back. Oh my god, there's so much.
Sammy, Peter. Diego.
That is exactly the hypothetical scenario I was grappling
Any of them look like a new watch? Yeah. Fingers crossed.
Is there an extra FRQ package?
There is. Do you know the binder number?
He's like 5 or
It's
6.
33. To the left of Oliver, there's that basket that says AP Cal AB handouts. It'll be in 33.
No, it's 31 minutes.
I was gonna dress up and then I like, oh, you had that shoe.
No, this is why.
I remembered I had a presentation, I psyched myself
It's like me wearing that Steelers. Steelers pullover that when I wear that Steelers pullover week 1, everyone is saying something about it. I won't wear it to school anymore.
15 is peaky turkey. Do you have the one that?
I bet you will care. We were all sitting.
Oh,
Yeah, that's
someone has to write like evil chair on it.
So we gotta stretch.
Something called really mad.
Honestly, that's fair. That chair is gorgeous. I put my backpack on this the whole time. What I'm gonna
Is this certain calculus student?
Yes.
It's you. It's you. It's definitely you.
I would know.
You are a certain calculus student.
It should also say a certain calculus teacher.
Alright, good morning guys. I see that most of you guys saw this, but assignments I'd like to give you some points for. It's 31 and 32 for today. 31 was some notes, so that should have been done just by being here and participating. 32 was the book assignment. So if you didn't already turn that in, please do that right now. Sometimes it gets really cold in here, and so I asked for a space heater the other day so that I could like slow it down a little bit on the cold days. And instead of giving me a space heater, they just jack the heat up. So it's kind of warm in here right now, but it should be cooling down. So.
Representing the Wolf Friends game. Please join me for a minute of silence.
Am I going to return 32 on Thursday before credit since I wasn't here on Friday? Because I did the first half, but I didn't do the second half. Or do I get half credit? I know it is a book assignment, so it's like basically one thing, but like I did the first half.
I don't know. I gotta look at the dates when you do it. Just turn it in when you're done.
Please stand if you're able for the Pledge of Allegiance. To the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you.
I was disappointed.
It's a good recovery.
It was like, I felt everything. I'm so sad.
Okay, last call. Any other homeworks? Am I waiting on anybody? Last call for full points. Okay, so what I was saying about the heat, again, I came in and it was really hot when I first got here. I bumped the thermostat down, but it takes a little bit of time, so I'm sorry. Honestly, usually my thermostat doesn't really even work, so some days, if it's been blowing heat all night, it is pretty toasty in here in the morning, so I'm aware, and I'm sorry, I just can't do anything about it. Okay, so we have talked about implicit, practiced it a little bit. You're probably tired of me saying those same steps. So we need to move into the second big part. Again, there's a couple little things, but the second big piece of Unit 3, which is called related rates. So this is not a one-day lesson. This will be something that takes a couple days to get better at. I guess I should warn you that related rates, some students tend to find them to be difficult. I don't really think so, but for some people, it is sometimes a harder lesson. So I only forewarn you of that so that you make sure you give your full attention until you are sure that you are in good shape. Okay, so before we even start talking about related rates and what the calculus we're going to be doing and how that's going to allow us to solve some real-world questions, related rates all basically start off with a geometry formula. So there are some geometry formulas they expect you to know. So if you don't know those, I need you to be aware that you're supposed to know them so that you can get that under your belt. So a common one is Pythagorean theorem. So make sure you know a squared plus b squared equals c squared. Specifically, make sure you know c has to be the hypotenuse. A and b are legs, c is the hypotenuse. For a circle, they expect you to know the area and circumference of a circle formula. So if you couldn't tell me either one of those off the top of your head, you need to put a star by that and make sure you rememorize it in the next few days. Square, area, and perimeter. Although I feel like the perimeter should just make sense. You add up 4 sides, you get 4 S's. Okay, and then we get to some of the 3-dimensional shapes like cube, cones, spheres, stuff like that. So I left some of this blank, but I want to give you kind of something that I never learned about some of these formulas that I figured out way later when I used to teach a lot of geometry, which can help you with 3-dimensional shapes so that you don't have to memorize as much. But basically, if you have something that's a sphere, meaning that it has 2 bases, I'm sorry, not a sphere, not a pyramid. Okay, so let me come back to that. If you have one base, so not a second base, this is like a pyramid. Okay, there we go. I just had a loss of words. This is a prism. If you have two bases, it's a prism. If you have one base, it's a pyramid. The volume of these shapes are almost the same formula, no matter what type of prism, no matter what type of pyramid. If you do capital B times H, capital B times H, where capital B is the area of the base, the only difference between a prism and a sphere is that a sphere is multiplied by 1/3. But if you think about volumes as area of the base times the height, that works for almost all three-dimensional shapes. So, like a cube, some of you probably just know this formula, but since a cube is a three-dimensional shape, and it's technically a prism because it's got a pair of opposite parallel sides, so that means two bases, the volume will be the area of the base, which is side times side, times the height, which is side, or side cubed. So I'm just showing you that that works. Area of the base times the height. Area of the base was side squared, the height was side, volume is side cubed. For a cone, since the area, well, a cone only has one base, so that's like a pyramid, so it's 1/3 area of the base times the height. And since a cone has a circular base, that would be pi r squared times the height. And then there's the volume of a cone without really having to memorize anything. And again, this is nice because then I could do cylinder. And a cylinder has two bases, so it'd work like a pyramid. It would be pi r squared h. It would be the same as a cone, but not times 1/3. It's pretty easy to extend if you think of them this way. Now, the most common one that students ask a lot, so I'm going to ask that you write this on your paper here, is sphere and it is 4/3 pi r cubed, but you can put an X through that, so write it on your notes, but put an X through it, because that is one they don't expect you to know. So we will do questions with spheres, but they always provide that formula when we do that. So if you don't know that formula, that one's not as big a deal. You don't have to know that by in your head. So if you remember all that, I guess you can put this handout aside. If there's one or two of these you didn't remember, you probably should leave it out to refer to. And then let's jump over to the notes for related rates, so we can start talking about what a related rate is and what the approach is. Okay, so used to, I would have a list of things up here that I think were good suggestions for you to do on related rates anytime that you kind of get stuck. But a couple years ago I took that off, and instead what I'd like us to do is just kind of start looking at these examples. Let me talk about what we're doing and how it works out. And the nice thing about related rates, even if you end up not liking them or thinking they're harder, related rates is very much a process. I can pretty much say, always do this step 1, always do this step 2, always do this step 3, always do this step 4, and then maybe do this step 5, and then you're done. And those same steps will work no matter what type of geometry shape you're working with, no matter what type of information is given to you, etc. So the main thing, and how this relates, why this is in Unit 3 for us, is, let me make a quick little connection with implicit, because if you understand why we created those y primes, then this is not going to be much different to you at all. So when we take the derivative of stuff with respect to x, like this, when you take the derivative of x stuff, it just works normally, but when I do this operator to y, it creates a dy dx. So basically, these variables need to match. So if you take the derivative with respect to x of x stuff, the variables match, and you don't need a dy over dx. But if you take the derivative of something, I'm going to generalize it now, not just the y, but if you take the derivative of something with respect to something else, so in implicit we were taking the derivative of y with respect to x. These variables are not the same, so we had to create that. Well, in related rates, we will always take the derivative with respect to time. What that means is, when I take the derivative of a geometry equation in a minute, unless the variable is t, I have to create that variable prime. So again, let me try to say that one more time up here. If you're taking the derivative of x stuff with respect to x, you don't need to worry about multiplying by anything. But if you take the derivative of any other variable with respect to x, you need a variable prime, so y prime. If this was a z, then this would be a z. You would need that variable prime, or z prime. So everything we do will be taking the derivative with respect to t. Okay, so let's just kind of dive into one of these. We've got a calculus student hits his calculus teacher in the head with a gigantic snowball. If the snowball is melting at a rate of 10 cubic feet per minute, at what rate is the radius changing when the snowball's radius is 2 feet? So, way too much to just try to reason through this in our head and try to figure out what's going on. So, you've got to read through here. You've got to find a geometry shape. So, what's the shape that would match up with, what's the geometry shape that we would call a snowball?
Sphere.
Okay, so I don't think this matters in this question, but I'm going to add it to your list up here. A lot of times, not so much on this one. Draw a picture, it's going to help. So here's my snowball, and if the snowball, so here's, I guess you could say this part can be kind of challenging sometimes. It's a snowball, which you guys just told me is a sphere. They tell me that it is melting this fast. I'm supposed to figure out how fast the radius is changing at the instant when the radius is 2 feet. So what is this describing?
Decay, or the rate of change of the volume.
Exactly. This is talking about volume, and it's not just volume, because volume would be like 10 cubic feet. If it's 10 cubic feet per minute, that's how volume is changing. So volume prime, it's the rate, it's a derivative, it's a how fast it's going. So 10 cubic feet per minute. So they give us that. We are supposed to figure out what the rate of the radius is changing. So am I trying to solve for r? I'm not trying to solve for r. What am I actually trying to solve for? Exactly. Not the radius, but the rate of the radius. So that's the difference between r and r prime. And then finally, when the snowball's radius is 2 feet. So when the radius is 2 feet. So I don't know what you want to call this, but I would say something like identify all given information. Okay, and our next step is we need to pick out a geometry formula. So I'm not going to pick Pythagorean theorem here because this has nothing to do with right triangles. Identifying this information is giving you a hint. It's a sphere. We know something about the volume. We know something about the radius. We know something about the radius. So what is a formula? What's a regular old geometry formula that you would have to use maybe on the ACT? What formula would that be?
Volume of a sphere.
Okay, and so volume of a sphere is one you don't have to memorize. So you got to start with the geometry formula, just write it down. Okay, now we have to take the derivative. I highlighted this. We are going to be taking the derivative with respect to time. That's important because if I take the derivative of a t thing, I don't need a t prime because I'm taking it with respect to t. But if I'm taking the derivative with respect to anything else, a, b, c, d, e, anything besides t, I need an a prime, a b prime, a c prime, a d prime, whatever. Those variables have to match. So the derivative of, so now I'm taking the derivative. Obviously calculus, we're in the derivative unit. We're going to be doing derivatives in every single question. So so the derivative of v would be 1, just like the derivative of x is 1, except I just took the derivative of v with respect to time. V and t are not the same variable, so I have to create a v prime. It's the same thing you did with implicit. When you took the derivative of y with respect to x, the variables didn't match, so you created a y prime. Here I'm taking the derivative of v with respect to t. Those are not the same thing, so it creates a v prime when you take its derivative. Okay, and then same thing over here. 4/3 pi is just a number, so this would be power rule. Bring the power down, lower the power by 1. Anything else? Okay, what would the chain rule include? You need an r prime, exactly. I just took the derivative of r stuff, so unless it was with respect to r, you have to include an r prime. We're taking it with respect to time. Only when the variables match do you not need the variable prime. So you do that, and if it's an easier question, you basically just get to plug in all of this stuff. They told me this was 10, this is a number, this is a number, they told me this, and they asked me to solve for that. So if you're lucky, you get to just plug in the things you need and solve for what you don't have. So this would be 10 over 16 pi, which is the same thing as 5 over 8 pi. So 5 over 8 pi, and this is how the radius is changing. So it wouldn't just be feet. Feet is when you're measuring radius. If you're measuring the rate of the radius, you need a time component. So if that was in minutes, this would be in minutes also. So the next question, I'm going to bug you about this all the way through these notes. The next question's probably not a sphere. It's probably not the volume of sphere formula. It's probably going to give us different information, but the steps are going to be the same. Picture might help. Pick out a geometry formula that ties together the information. Take the derivative with respect to time. Plug in the given information, and then if you're lucky, the last thing left there is what the point of the question was. So that gives you something to solve. And likewise, notice 5 over 8 pi is not something you would ever guess. No matter how much time I gave you to just mentally try to guess it, you're never going to do that. So, all right, so completely reset, and then I need you to see how these steps that we talked about are similar, even though it's a completely different question. Okay, a stone is dropped into Lake Fayetteville, causing concentric circular ripples. That just means that you have circles within a circle, like when you throw a stone in the water. Okay, whose radius increases by 2 meters per second. So that is describing how the radius changes. Please also just make a habit of putting the units here. Putting the units here will make your life easier over time. How fast is the disturbed area growing? So they don't want to know what's the area, they want to know how the area is growing. So A prime, derivative represents the rate, otherwise it would be a stagnant constant. Specifically, at this time, when the radius is 5 meters. So I drew a picture, probably did nothing, but it did make me think about the shape, I guess. I know something about radius, I know something about radius, and I want to know something about area. So what is a formula that works with this type of shape, with these type of variables? Okay, and what is the area of a circle formula? Pi r squared. So there's my geometry formula. You got to pick a geometry formula in every one of these questions. Almost all of them will match up what was on that first handout, the geometry formulas you're supposed to know. Okay, every time we're going to take the derivative, and if it's a related rate, so if time is changing, or if it's a function of time, or if it just tells me to take the derivative with respect to time, any of those things are how I know it's a related rate. So the derivative of a would be 1, just like the derivative of x is 1, but I'm taking the derivative of a with respect to t. A and t are not the same variables, so I need an a prime. Pi r squared, pi is just a number, so this is power rule. Bring the power down, lower the power by 1, and then realize you just took the derivative of r stuff with respect to t. R and t are not the same thing, so you have to put in r prime. That's really an application of chain rule, because you're taking the derivative of the inside, and the inside of this is r. So times the derivative of the inside. It's really just a different way to say chain rule. Okay, and the easiest questions, you're just about done. You're going to plug in the stuff they give to you. So I know 2 is a number, pi is a number. I know r is supposed to be 5 meters. I know r prime is 2 meters per second. And the point of this question was for me to try to figure out how fast the area is changing. So I've got an equation. Only thing I'm missing is what they asked me to solve for. Put this in here. So 2 times pi times 5 times 2 would be 4 times 5, which is 20 pi. Now notice, if you put these units here and you put the units here, look how easy it is to figure out your units over here. Your units are meters times meters, which would be meters squared, which makes sense. Area is usually square units. 25 square inches, 16 square centimeters. Area is squared units. And because this is a rate, there should be a time unit as well. But if you put the units here and then you put the units here, basically the units are going to be done for you on your answer too, and you're not trying to do that again. So once again, I don't remember what question 3 is without reading it, but next question is probably a totally different geometry formula, totally different shape, different information. But if we can take the derivative with respect to time, plug in the information correctly, then we can solve and give an exact value of something that's very hard to do by hand. Okay, part 3. All edges of a cube are expanding. Okay, so again, sometimes a picture helps. I think when we get to the back page, you'll see some where it really helps. But there's my cube. The edges, which I'm going to call S, I guess you can use anything, are expanding at a rate of 3 centimeters per second. Now this contradicts. Be careful here. The side length's not 3 centimeters per second. That doesn't make sense. Side length would be 3 centimeters, not 3 centimeters per second. This is how the side is changing, how it's expanding. So don't call it S, call it S prime. How fast is the volume changing? So what's the rate of volume when the edge, so when S is 1 centimeter. So sometimes a picture is necessary, probably not here, but between the picture and the given information that we extracted out of their statement, I've got to figure out a geometry formula that's going to combine this type of stuff together. Not going to pick Pythagorean theorem because there's no right triangle. I'm going to pick something like, this is a cube, I want to know something about volume, it's probably volume of a cube. So you've got to start with the geometry formula that tries to tie these variables together. You need to take the derivative of both sides with respect to time. So the derivative of v with respect to time is v prime. And the derivative of s cubed with respect to time, this would be power rule. Bring the power down, lower the power by 1, and I just took the derivative of s stuff with respect to some other variable, so I need an s prime. If we're lucky, the only thing we won't know is the thing that they're asking for, which is the case here. 3 times 1 squared times 3 would be 9. And then notice I put all of my units here. Here's centimeters cubed times centimeters, which would be, centimeters squared times centimeters, which would be centimeters cubed, which should make sense. Volume has cubic units, but since this is a rate of change of volume, it doesn't just have a cubic unit, it also has a time element. But again, if you write those down, then it's right there. Centimeters squared times centimeters divided by seconds, and you have the units. Okay, so I do, well, let me cheat a second. Okay, so I've been saying that, trying to emphasize the same stuff. Geometry shape, geometry formula, take the derivative with respect to time, plug in all of your stuff, no matter what type of question it is. That was true for the first 3. But then I was saying, if you're lucky, at the end, you just plug in the stuff they give you and then solve for your answer. Sometimes you have to go one step further than that, and you have to extract one extra piece of information. So we will see that in question 4. Now, this is probably the most popular type of related rate. If I had to guess, I think they put this type of question on the AP exam every single year. So I think they always ask this type of related rate question. So, which means we probably are going to have one on the test too, or at least one. Okay, we've got a ladder that is 25 feet leaning against the wall of a house. The base of the ladder gets pulled away from the wall at a rate of 2 feet per second. How fast is the top of the ladder moving down the wall when the base is 7 feet from the wall? So somebody's got a ladder against their house, they're pulling it away at a certain speed, and we can figure out how fast that ladder is falling down to the ground. So this is probably the first question where a little bit of a picture might help. So here is my house. Here's my ladder. And then I can start labeling some of this stuff. The ladder is 25 feet. The base of the ladder is getting pulled away at a rate of 2 feet per second. And I want to figure this out. How fast is this ladder falling down? So if this is in feet per second, this would be feet per second also. So how many feet per second is this falling down? At the instant, so this changes, by the way. It doesn't fall at the same rate the whole time. When the base of the ladder is 7 feet away from the wall. So for this question, a picture makes more sense because I can't just say radius is this, volume prime is that. You know, I can't just say define a lot of variables because I don't know what you would call a lot of this stuff, but I need a picture. So ladder against a thing, I labeled all the information. Now that I have done that, what geometry shape do you think we're going to use? Okay, more specific than triangle, right triangle. And what's one of the most common formulas that involves right triangles? Pythagorean theorem. Just when you thought you got away from a squared plus b squared equals c squared. Okay, what did we do on the front side of this after we got a geometry formula? What did we do to this? Take the derivative with respect to time. So a squared would become what? 2a what?
A prime.
Perfect, a prime, because a is not the same thing as t, so you need an a prime. If you can do that, you can do b prime. Power rule. Derivative of b with respect to t needs to create a b prime because b and t are not the same thing. And then one more time with c squared, bring the power down, lower the power by 1, and realize c and t are not the same thing, so you need a c prime. Now, a lot of people don't even write the 2's. Do you guys see how everything has a 2 and you could just divide everything by 2? I don't do that, but since it technically works, I guess you really can just jump to that step. But Pythagorean theorem, the derivative with respect to time. So whatever the length of A is times the rate it's changing plus the length of B times the rate it's changing will always equal the length of the hypotenuse times the rate it is changing. So, I don't know, which one of these three sides has to be C?
25.
Hypotenuse has to be C. The other two don't matter. One's A, one's B. So let's start plugging stuff in and see how close we are to having our answer. So A, I know, is 7 feet. A prime is 2 feet per second. B, I don't know this length or its rate. In fact, if I knew its rate, I'd be done, because that's the point of the question anyway. Maybe I'll highlight that so I remember what they're trying to get us to do. So I don't think I know either one of these. That's kind of a problem. Okay, and then C is 25 feet. What is C prime?
0. The length of the ladder wouldn't be changing. So
Exactly. Does everybody understand that? C prime is 0. The ladder doesn't just start changing lengths as it falls down. So the ladder's 25 feet, it's always 25 feet. So 0 feet per second. Because it doesn't change. Now, here's the problem that we didn't have on the front page. And honestly, this is the only way related rates get harder. I drew a picture, I picked out the correct geometry formula, I took the derivative correctly, I plugged all the information in correctly. I know what I'm trying to solve for. I'm trying to solve for this, b prime. But I can't solve this equation if I don't know b prime and I don't know b. I can't solve this with two unknowns. So occasionally, you've got to dig in and do a little bit more work. If I can figure out the length of b, then I can actually solve for b prime, which is what I've been trying to do this whole time. So, you got to kind of look at what you've got and think about what else we could do. How could I find this length of b? Right, and I'm actually going to draw this down. I'll erase it because I'm going to need the space. But notice, in all of this mess, there's a right triangle, and I'm interested when this is exactly 7 feet and this is 25 feet. So you really can just do Pythagorean theorem to find this length, to figure out how many length. So this is a Pythagorean triple, I think. 7, 24, 25. Does that sound right? So sometimes you've got to do that little bit of extra work to say, okay, there's still one more thing missing. Like we just did for side B. I'm going to erase this because I'm going to need the space. And now it's just a matter of solving this equation. That goes to 0. I'll subtract this stuff over. This would be negative 14 feet squared per second. This was 24 feet. So b prime is negative 14 over 24, which reduces to negative 7/12. And feet squared divided by this feet becomes feet. Feet squared divided by feet would just become feet, and then it's per second. So a rate, if you keep up with the units, again, then you don't have to do any more work if you need the units, but also it can kind of help you check your work. Because if you think the answer is -7/12 feet, your answer shouldn't be in feet, so that could be a hint that you lost something else. But geometry formula, take the derivative with respect to time, plug in everything, hope that you can solve for your answer, but if you need one more piece of information, then you just gotta have to go find that other piece of information. Okay, we are going to combine this next one onto this one, just because I want you to see that it's all basically the same work. All we're changing is this 7 to a 15. What if it was 15 feet away from the wall? How does that change it? So the picture would still be the same, but now this would be 15 feet, which is side A. So A is no longer 7 feet. A would be 15 feet. Okay, what else would that change? Doesn't that change the side of B too? And I don't know, maybe this isn't a Pythagorean triple, but 15 squared plus what squared equals 25 squared? Is that 20? Yeah, that was a good guess. So if you change the length of the triangle, it also changes this length, because it's got to fit Pythagorean theorem. It's 20. So I don't know, that still goes to 0. We just update these numbers. This side still goes to 0 because the rate of the ladder doesn't change. This would now be 20 feet next to B prime. This would be 30 feet squared that I would subtract over, so negative 30 feet squared. Divide both sides by 2, 20. So notice I had to change a couple things, but otherwise almost all the work was the same. Picture, formula, derivative, plugging in all the numbers still go in the same place, but changing the length of A changed the length of B because you're talking about a different instance. And when you change the length of A and update the length of B, then the rest is just arithmetic and solving. But this idea of a ladder against the wall, Pythagorean theorem, definitely the most common type of related rate. If you did a good Google search for like released AP questions and you put this in the search, you'd probably find dozens of released AP questions that asked you to do the same skill. So I guess in that sense this one's a little more important. So is there anything you want to clear up about 4 while we're still here? Okay, let's look at one more question then. Oh, and I always forget to change this. This is supposed to be an IV. This is supposed to say 8,100 square feet. Okay, a baseball diamond is 8,100 square feet, the 90 feet squared. They were trying to think of the sides of the square when they wrote that. CJ runs from first base to second base at 25 feet per second. How fast is he moving away from home plate when he is 30 feet from first base? Well, if he's running exactly away from home base, like directly away from it, then he's running 25 feet per second. But if he's running at some kind of an angle, some of it's horizontal, some of it's vertical, and that changes. So, based on the other questions, again, notice this one has nothing to do with any of the others we've talked about, but a picture still helps. So here's my baseball diamond. CJ is somewhere between first and second base, and I know that he is running at 25 feet per second, and I want to know how fast is he moving away from home plate So how many feet per second is the distance between him and home plate? Specifically at the instant when he is 30 feet away from first base. So he's a third of the way there. Okay, so here's my picture to my best of my ability. I tried to identify all the information and put it on the picture to the best of my ability. But at some point, we've got to pick a geometry shape and a geometry formula that we think might include all of these values. So, what do you guys want to go with? What kind of shape? Okay, and I agree. So, you first read this, baseball diamond. Diamond is a square. You might think it's some square formula. But if we need this length and this length in some kind of a formula, we have a right triangle. So once again, Pythagorean theorem. And not only is the latter questions the most common type of questions, but Pythagorean theorem is probably the most common formula you can use. Just like all the questions, we need to take the derivative with respect to time. So power rule, and we need an a prime, b prime, c prime, because none of those are t, and we're taking the derivative with respect to t. Feel free to divide everything by 2. This makes it a little bit easier. Doesn't matter. And then we got to start plugging this stuff in and seeing if we can solve for what they want yet. So now I don't really care about this this baseball diamond anymore. I'm really kind of focused in on this right triangle. So I've got to make this side C, it's the hypotenuse. I'll call this side A and this side B. A and B don't matter, C has to be the hypotenuse. So in place of A, I could put 30 feet. In place of A prime, I could put 25 feet per second. I don't know the length of B. I don't know the rate of B. C prime is what I'm trying to find, and I don't know C either. So this rate, so this is what I'm trying to solve for. So obviously that's going to be the last domino to fall. So somehow I've got to look at my work and try to figure out how am I supposed to get the length of C, the length of B, and the rate of B so that I can solve for C prime. There's 3 missing things there. Well, we could use this. We haven't used this yet. If the area of this baseball diamond is 8,100 feet, how does that help? Okay, so that means each side is 90. So that's one way you could find B. I'm not going to rewrite it, I'm just going to plug it in. Okay. What about B prime? How is this length going to change? It's not going to change, right? So this actually is going to go to 0. Maybe I should have done that first, because then I wouldn't even needed to know the 90 multiplied by 0. Oh, actually I do need the 90, because I need to find C. Now, if you just focus on the right triangle, I'm redrawing it to help you see the important stuff. Sorry, I'm not an artist. If this is 90 and this is 30, we can use Pythagorean theorem to find this length. So I'm just going to do it real quick as a 30 squared plus 90 squared. I know it comes out to be the square root of 9,000, which is a decimal. I'm just going to call it that, square root of 9,000. But then at some point, and again, this is on the harder side because I had to dig in and find a little bit more information, but everything else has been consistent. So this goes to 0. So my answer times the square root of 9,000 is supposed to be 30 times 25, which is 750 feet squared per second. Also, I should put feet here as well. If I'm going to keep up with my units, I should keep up with my units. So, divide both sides by the square root of 9,000 feet. And so, whatever 750 divided by the square root of 9,000, feet squared divided by feet would just be feet. And then it's got per second. My answer is a rate, so my unit should be a rate. If my units were feet squared, feet cubed, that would be problematic because I wasn't finding the change in area or the change in volume. Or if it was just feet, that would be a problem too. It's got to have a time component to be a rate. So again, some people just think that these are difficult, but the best advice I can give you to start off is just think about the consistency. Picture geometry formula, derivative with respect to time, plug in the information, solve for what you want, unless you're missing too much, and then you got to try to find another piece or two like we did on these last couple questions. All right, so moving forward here, you will need a blank piece of paper for the next handout. There is not enough room to do these. Some of these yes, some of these no. So now I need you guys to practice. On your blank sheet of paper, you go ahead and start the first few questions. So the way this is laid out, these first few questions, I don't know. I don't want to say that they're easy or not, but these are not real AP questions. So start with these 6, I believe, and notice at the bottom of the page, it has the answers. So when you work question 1, if you don't get 8 pi feet squared per second, you might compare your work with your neighbor, look it over again, and or call me. But the answer to all 6 of those are on the bottom. So obviously do those 6 first. And then after that, the back of that page has other questions. But these are all real questions from past AP exams. So that's why they're multiple choice, and they will vary in difficulty. Some of them are pretty tricky, some of them are very straightforward, but you can start to see how competent they expect you to be on these for the AP exam. So let me get our homeworks put in while you guys start on these few. Again, if you get stuck, consider working with your neighbor for a minute till I get the homeworks in, and then just hopefully get as far as we can through this today. But this worksheet's not going to be homework. We're going to spend a good chunk of time on it. It takes a while to do these.
I got it. Okay, I have one question, so I'm gonna do one.
Bless you. Bless you. If you get stuck on one, please just move on to the next one. I'll come around and help in just a couple minutes.
Oh wait. Yeah, no way. I'm done. No, it's just something. I just did it. It'll be fun. I said that it'll be fun.
Uh-huh.
For a pile of gravel, would that just be a cube?
Sorry?
One of the questions asked about a pile of gravel, would you just use a cube for that shape? Or,
If you pay someone to bring you gravel to your house and they dump it in your yard, is it a cube?
well, I don't know what shape it would be.
It's a cone.
Okay.
Are you looking at number 3?
Yes.
Cone.
I did one question and I read what no, okay. I'm trying to. Yeah, I'm doing fine. I'm
Only at like 10, but it stays like 10.
The radius and the height.
I'm going to try to come around and help you guys wherever you're getting stuck. Honestly, wherever you're stuck is probably very likely a different place than somebody else. So, has anybody not finished and gotten the right answer to question 1? I want to make sure I come and help you finish that one. Nobody needs help with question 1? You checked your answer at the bottom of the page? Okay. Number 2. Anybody not get that answer to number 2? Okay, what about number 3? Oh, okay, there's too many to go. Okay, I'll do it up here. Or we'll talk about it up here. Alright, number 3. Gravel is falling in a conical pile, so a cone, at a rate of 100 cubic feet per minute. Find the rate of change of the height of the pile when the height is 10 feet. Assume the coarseness of the gravel such that R equals H. Okay, so conical pile, again, to me that sounds like they're talking about cone. And they say the rate of gravel falling is 100 cubic feet per minute. So that's how the volume is changing. They're adding 100 cubic feet per minute, which makes sense. Volume is always cubic. If volume is a rate, it needs a time element. Find the rate of change of the height. So I'm not trying to find h, I'm trying to find h prime, the rate of the height. Specifically at the moment when h is 10 feet. Okay, so the fact that they're trying to use cone and volume, this is probably volume of a cone. So you either need to memorize this formula because it will not be provided for you, or you could realize it only has one base, so the volume will be 1/3 of the area of the base, which is a circle, times the height. Anything with one base like this is 1/3 area of the base times the height, and then you don't have to memorize that. Okay, so what you could do, now here's what's going to happen if you take the derivative too quickly, or if you just, you know you're going to do the derivative, so if you jump into it instantly, here's your problem. Well, first off, these are constants, so I'm going to pull them out front, just like I always do to make my life easier. And then to take the derivative of r squared h, you would have to use product rule. So you could take the derivative of r squared with h left alone, and then the derivative of h with r squared left alone. And this is true but it's got some problems. Some of this stuff I don't know. Do I know v prime for sure? It's up here. Do I know r?
It said r is equal to h.
Okay, so technically I know r also, right? R and h are the same. Do I know r prime? Okay, so if there was a way for me to find r prime, that would be great. I could plug in 10 for h, 10 for r, 10 for h, but I don't know of any way to solve for r prime, personally. Maybe you do. So the trick here, and probably why so many of you had your hands up, is just like when we first did power rule, and product rule and quotient rule and all that kind of stuff. If you just immediately always take the derivative right away, sometimes you're going to make your life way harder than it needs to be. If you can simplify it first before the calculus, that's probably going to make things easier. So if r equals h, why don't I just call, well, I could either change this h to another r. The problem with this would be, this is like r cubed. I could do that, but what's wrong, or why is this derivative not helpful?
There's no h prime.
Yeah, I'm trying to solve for h prime, so substituting h with r is not a great idea. But you could also replace r squared with h squared, since r and h are equal the same in this question. So you could also call this 1/3 pi h cubed. Now when you take the derivative, again, these are just a constant, so this is just power rule. Bring the power down, lower the power by 1, and we just took the derivative of h with respect to t, so don't forget the h prime. And now we have everything that we need. This is 100, this is pi, this is 10 squared, and h prime is what I'm trying to solve for. So divide both sides by 100, divide both sides by pi, it looks like h prime would be 1/pi, which is what they got. So that could have been a lot harder question. The fact that they told you r equals h allows you to take the volume of a cone formula and just get all the r's out of it. Just switch the r's to h's, and then that works out nicer. Okay. I would like to leave this number 3 on the board in case you need to look at it a little bit longer, but try to use that to make sure that you make sense of number 3. And then if you still need help with number 3, please call me over in the next minute or two as I come around.
I can't find it.
Figure it out.
Or well, no. That's what it is. 400 over 3 and down. A prime is going to be 0 plus B prime times B would be 400 plus C prime. And then if you try and solve for C, you get like 25. But well, because you have the base is 150, and then the try, and then the balloon is rising and trying to find the distance. Yeah. Have you done 5?
I'm working on it right now.
Yeah, I'm stuck.
How do you know that?
Oh, it's 2 seconds.
Oh, when the balloon is 50. Oh, that's not I can't do the numbers in my head that fast, so this one. 150 squared. 50 squared. Okay, so for that. Okay. So then you just divide this for it. Okay. The other thing, 150. Yes. 400. Okay. So 400 over the square root. Now the quick check would be, I would put that in your calculator, see what decimal you get. S squared. So. And then that's probably which one put theirs in, and it should be the exact same decimal, another equivalent. And then I can tell you, okay, so you at least know that they're equivalent. So what they're doing here is they're simplifying this, they're breaking the square root down as much as possible, and they're rationalizing. So when you multiply the top and the bottom by whatever square root is left, or no, yeah, that's how they end up with the square root. So I would practice that to make sure you can do it on the test. If you had a calculator, that's a quick way to see what your answer is. Okay, anybody still stuck on 1, 2, or 3? Please let me know so I can come get you past that point.
Okay.
I got this time and couldn't figure out how to get the extra plate off.
Oh. At first I looked like oh, wait.
Oh, I just wanted to get the extra. What? Did I put in the wrong number?
For the Y next
Oh, I put in 18 instead of wait.
Instead of what?
Why did I put 18?
Instead
Wait.
of what?
Wait, I did do it right. Yeah.
No, what?
Oh, no. I see what it is. I put 18 because 8 because I thought. Yeah.
No, I got 0.8 grades, nowhere close to that. So 0.
What is that?
Well, is that as a loss of decimal? Yeah. I got 8 over 8. That's the. Wait, from what I got, 400 over 20 plus 100.
No, I don't think I.
Wait,
I need a.
because the
Is
formula
that
is
2.53?
first.
Oh, that's what I
Did
got
you
too.
say no, you read that way?
No, because I did 50 times.
Just write it like how the answer.
Yeah.
Okay.
So
I'm gonna ask
I did the
this. I
same.
just like swear. You know what I'm saying? Look at this.
Mrs. Zai, did you get?
Wait, actually, maybe I am very close to the wait, actually, I think I gave it.
So I was looking at number 5, and me and Jacob got the same answer. I didn't leave like the square root number. I plugged it into a calculator. Should I leave it in like a form like square root?
It depends. If it's a free response, you don't have to simplify at all. If it was a calculator
Okay, I
question,
just
you
get
always run 3 decimal places.
I can do that.
So I think, does Thomas ask you to do that free cal?
Yeah, 3 places.
Yeah, that's what they expect from you. So
Okay.
if you do round, it needs to be to 3 decimal places, but you also need to realize that that question could be a no calculator question.
Yeah.
So you would need to know how to simplify with radical and rationalize. probably.
Okay. Gotcha.
We'll get back.
What was is there an answer?
It's supposed to be.
Yeah, I got it.
Sorry, your card.
It's just, I mean, it's the same as the one number 4. Honestly, I didn't even run out the variables. I just didn't even I figured it out.
Oh, I got it.
Okay, wait, what?
You have to simplify the square root.
Well, that's what I did, and I'm just gonna. Area.
Yeah, I think you just have an extra 0.
Simplify the square root. I got 10 times root 215. And then get the root 10. And then multiply by root 10.
If you're just finding the area, then you only need to decide, right? That's what you said. I was thinking it could be over.
Oh, it's gonna be 6. I need to word it.
Can you do number 5?
That's what I was thinking, but it's.
Can I do number 5? I hope so.
Oh, is it? Yeah, we got it. We can try it.
So, this is the room, it's going up to be. I guess we already did all that.
Yeah. Yeah, I was confused about that too. That's it.
Let's see. So he is 150 feet away. The balloon goes up at 8
Wait, so are we still typing without already?
per second.
Let me make sure I got it. Yeah.
How many feet per second does that change? That's the right triangle. When the balloon is 50 feet high. Okay, does your picture, oh, I'm sorry. I'm just talking to myself here. Does your picture look like that?
Yes.
Okay. So right triangle, probably Pythagorean theorem. A squared plus b squared equals c squared. You took the derivative, divide everything by 2. You got to this part.
Yes.
Okay, so what we'd have to do, so I'm going to call this C, A, and B. So A is 150. What about A prime? That'd be 0 because that's not changing. Good. B is 50. B prime is 8. C I don't know, and C prime I definitely don't know because that's what I'm trying to solve for. But there's a way to find C, so you could do Pythagorean theorem here. 50 squared plus 150 squared.
It's the square root of 25,000.
Okay. Square root of 25,000.
Or will it be? Or yeah.
That sounds good. Okay, then C prime would be 0 plus 50 times 8, which would be 400, over the square root of 25,000. Oh, okay, well if you made it that far. The only other thing I think they did is they broke down the square root of 25,000. So,
I broke it down to like the 50 square root of 10, but then when we simplified it, it was like 40 square root of 10 over 5, but it's on the paper it says 4 square root of 10 over 5, so I don't know how to get that from 0.
hold on, I need a second to catch up. We got 1, 2, 3, 4 5s, so that's like a 25. 1, 2, 3 2s, so that's times 2 is 50. And then it leaves behind the square root of 10. Did you get 50 square root of 10 when you were, okay, perfect. So 400 over 50 could reduce to 40 over 5. You're okay with that too?
Yes.
Okay, now looking at their answer for question 5, they have the radical in the numerator, so I think they're probably going to rationalize here. So rationalizing honestly isn't that important in calculus, but sometimes in math, if you've got a square root in the denominator, you need to multiply the top and the bottom by that square root, because then square root of 10 times square root of 10 just becomes 10, times 5 would be 50, and then now this 40 could reduce out this 50 and make it 4 over 5, and that's where it comes from. So it just sounds like the rationalizing step, which again, only is important in multiple choice, but sometimes they might do that to the answer, so.
Oh no, they got what I got. Actually, no, I guess it.
Two sides of the school. I hate it.
You don't have wait, is that? Oh, you have 1 through 6 on 2 sides of the paper, and I have 1 through 6 on half of 1 side of the paper.
Like, increasing, is it over here or?
You do like 2 hours. Well, but that's actually, yeah, but that almost makes
Maybe it's like a right triangle.
When I get sad, I gotta get tired.
Yeah, that's what I'm thinking, there's two.
Probably one of the sad. Yeah.
So like, you have this one and you have this one. So we have like two triangles like this. Like, I think it's like right triangle here. Right triangle
Okay, we got about 5 minutes here, so all I'm gonna ask you to do for homework is please try to just do one more question. So I'm only asking you to do one more because I want you to think about it again after class. Seems like you guys are very productive today, you made good progress. Again, we'll have to spend another class or two just on these question types to feel better about them. So do one more for me, otherwise you don't have to finish any of that up. I do have a puzzle for you today. This is not the one I was going to give to you, except I watched the video to it last night because I was curious how they proved the answer. And in their proof, it's almost identical. A lot of their work is almost identical to one of the questions you just turned in for homework today. So I will send you the video that explains the answer because I'm hoping that you watch it and I'm hoping that you recognize that from your homework last time. Something that you just wouldn't have thought of would have been related. But this is a non-calculator puzzle question. You're supposed to figure out what's bigger, 3.14 to pi or pi to the 3.14. No calculator.
Because he was going around the corner with his hands up, he was like especially like these guys yeah, they told him to stop putting his hands up. And then they stopped him and like talked.